So here we're going to look at increasing and decreasing parts of functions as well as extrema, meaning kind of maximums and minimums. So for increasing, decreasing, the easiest way to think about it is like reading left to right, like you do a book. So as x is moving to the right, what is the function doing? Are the y values getting bigger or smaller? So in this first example here, as we walk to the right-hand side, our outputs are getting larger and larger and larger. So that suggests that this is increasing. With this next one, as we're walking along to the right here, the y values are getting larger and larger and larger, and that would also be increasing. Below to the left here, so we want to start over on this left-hand side, and as I move to the right, the outputs are getting smaller and smaller and smaller, so that would be decreasing. And then for this last one, same idea of going to the right-hand side, so I have my y value, and I can see that they're getting smaller and smaller and smaller, so this would also be decreasing. So this is going to occur over an interval. We're going to use interval notation for these to describe what parts of the graph are increasing versus decreasing. But to know where it's increasing versus decreasing, think of this reading left to right, and then what's happening to the outputs. Are they getting bigger or smaller? Alright, we are going to have two types of maximums and minimums. So local is where you think of kind of zoomed in. In that section of the graph, it's the largest value, whereas the absolute maximum is the largest value out of everything. And then same thing for minimum. Think about kind of zoomed in and what would be the smallest value, and then absolute minimum would be the smallest value overall. So with this graph, let's look for local maximums. There can be more than one local maximum, and really it's maxima, but I'll just leave it like that. And same thing for minimum. There can be more than one when it's local. And then absolute maximum, for which there's only going to be one value. Absolute minimum, which there will also only be one value. And then let's also practice increasing versus decreasing with this graph. Okay, so for the maximum, minimum, these are going to be coordinates. So for local values, what I would do, like I said, is I would kind of think of zoomed in. Like here, it looks like I have this local minimum right here, so just for this section, it reaches the smallest value. However, what you'll notice is there's a hole right there, so we're not actually defined there. So with that, this isn't going to be a local minimum. However, if that was filled in, if this was just a smooth curve here, then this would be a local minimum. Then we go up here, and that right there is going to be a local maximum. So we're going to have this local maximum at -1, +3. Then I'm going to look at my graph, and here it goes to a point, this will be a minimum. So this will be a local minimum at 1, -5. And then if I go up and up and up, and then the graph ends. But even though this might seem like a maximum, since we don't know the behavior beyond it, it's just a coordinate. Okay, so from what we discussed there, local maximum occurs at -1, +3. Local minimum at 1, -5. Now, absolute maximum, that's where this point can count, that's at the end here. Basically what I want to do for local maximum is see where's the largest y coordinate occurring. And what's happening is with all these points, it hits this largest value right there. So at 3, positive 5, we're going to have an absolute maximum. Then for absolute minimum, what we're going to look for is the absolute smallest y value, which is actually at this coordinate 1, negative 5. So for absolute maximum, that'll occur at 3, 5, and absolute minimum 1, negative 5. So just take note that sometimes the local and absolute values will match up, and sometimes they won't. It'll just depend on the graph. Alright, increasing, decreasing. So what we could do is read this graph. And what I mean by that, I'm going to just kind of start at this furthest left point and then read along. So I'm going to start here at negative 4, and what I can see is we're decreasing, 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 and then when we hit negative 3 there, it switches to increasing. So I'm just going to make this little note here that between there we are decreasing. And then it switches to increasing until we hit that local maximum of negative 1, positive 3. So right here, it's going to switch to increasing, and after that local maximum, it's going to switch to decreasing. So it's going to get smaller and smaller and smaller and smaller until we reach positive 1. So we have this decreasing section. And then it switches to increasing until we end at 3, 5. Oops, went too far, increasing. So what this does is it gives me an idea of how many intervals I'm going to have. So I have 2 intervals of decreasing, 2 intervals of increasing. Increasing occurs starting at negative 3 and until we reach negative 1. So I'm going to have this interval from negative 3 to negative 1. Now, this is interval notation, so I could use the square brackets if I wanted to include the values. Now, negative 3, our function's not defined, so I definitely want to use parentheses there. But if you notice at negative 1, my function is defined. However, at negative 1, at that point right there, it's technically neither increasing nor decreasing. Like if you imagine throwing a ball up into the air. In terms of height, it's increasing, 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 and then when it hits the top, it's like it floats for a second. It's not going up, it's not going down yet, it just kind of hovers, and then it starts decreasing. And that's how we want to think of this piece right here, is that we're increasing, 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 it's not doing anything, and then it's decreasing, decreasing, decreasing. So with our interval notation, we don't want to actually include that point where it switches from increasing to decreasing. It's not doing either of them. Alright, then we start increasing again at x equals positive 1 up until x is positive 3. Now, same idea in terms of including the cutoff point. At positive 1, at that point it's neither increasing nor decreasing, it's switching. Same thing at the end here. Like, we don't know what happens beyond this, so our increasing is going to start, our increasing is going to stop right before that point there. So we're not going to include the endpoints. So when I want to include another interval, I'm going to use the union symbol to show that I'm also going to include from x equals positive 1 to x equals positive 3. So in terms of notation, this is a lot like what we use for domain of functions. We're using the cutoff of the x values. Alright, decreasing, same idea. We're going to have between negative 4 and negative 3. So it'll be decreasing between those values. And then we'll also see decreasing from negative 1 to positive 1. what you'll notice is increasing and decreasing tends to switch trends. Like these spots where we're switching from increasing, decreasing happens at these local maximums and minimums. Like if this was a local minimum, that's where we would switch. Local maximum, we'd be switching. Local minimum, switching. So if we want to find these spots where we switch from increasing to decreasing, look for a local maximum or a local minimum.